Imagine setting foot on Mercury, the closest planet to our sun. Could humans survive for 2 minutes on this fiery world? It's a tantalizing question that tickles the boundaries of our curiosity and scientific understanding. Mercury, a world of scorching heat and frigid cold, is a hostile environment that seems to defy the very notion of human survival. Yet, in the realm of the hypothetical, we dare to explore this possibility. Mercury's proximity to the sun subjects it to extreme conditions, with temperatures reaching blistering highs during the day and plunging into the abyss at night. Its minimal atmosphere offers little protection, leaving its surface exposed to fierce solar radiation and micrometeoroid bombardment. It's a picture of inhospitable extremes, a stark contrast to the life-sustaining environment we are accustomed to on Earth. Join us as we embark on this speculative journey, exploring the boundaries of human endurance and ingenuity. To understand the challenges of surviving on Mercury, we must first delve into its harsh and unforgiving environment. This small, rocky planet, the closest to the sun, is a world of extremes. The sun's proximity results in staggering temperature variations. Imagine a world where daytime temperatures soar to around 800 degrees Fahrenheit, hot enough to melt lead. Then, as night falls, temperatures plummet to a chilling -290 degrees Fahrenheit. It's a roller coaster of extremes in a single day. Now picture a place almost devoid of atmosphere. Mercury's thin exosphere, composed mainly of oxygen, sodium, hydrogen, helium, and potassium, provides little protection from the sun's intense radiation or from the bombardment of micrometeoroids, tiny particles that pepper the planet's surface. This lack of a substantial atmosphere also means that the sky is black, even during the day, and the stars are always visible. It's a starkly beautiful but deadly environment where humans, as we know them, cannot survive without significant protection. But the threats don't end here. Mercury's close proximity to the sun also exposes it to a barrage of solar radiation. Unlike on Earth, where our magnetic field shields us from most of this radiation, Mercury's weak magnetic field offers little defense. This radiation can cause serious harm to human tissue and DNA, posing a significant risk to any life form exposed to it. Furthermore, the lack of atmosphere allows micrometeoroids to strike Mercury's surface at high velocities. These tiny, high-speed particles can cause damage to equipment and pose a potential hazard to astronauts. Given these extreme conditions, survival on Mercury requires innovative solutions and meticulous planning. But as we venture into the realm of the hypothetical, let's explore what strategies could possibly help humans survive, even if just for 2 minutes, on this inhospitable planet. How might humans prepare for a brief 2-minute visit to Mercury's scorching surface? Now that's a question that thrusts us deep into the realm of speculative science and engineering. Let's dive in. Surviving on Mercury, even for just a couple of minutes, would require a mix of meticulous planning, cutting-edge technology, and a dash of audacity. To withstand the merciless heat, we'd need specialized suits. Not your average spacesuits, mind you, but ones that come equipped with advanced insulation and cooling systems. This would help protect astronauts from the extreme temperatures that can soar up to 800 degrees Fahrenheit during the day. But a suit alone won't cut it. We'd also need to create temporary habitats or shelters. These would offer an extra layer of protection and a brief respite from the planet's harsh conditions. These habitats would need to be constructed from heat-resistant materials, capable of withstanding the intense solar radiation and the constant threat of micrometeoroid bombardment. Now you might be thinking, well, that's all well and good, but how would we even get these habitats to Mercury? To which I say, welcome to the world of space logistics. Moving materials and equipment across the vast distances of space is no small feat. It would require careful planning, precision, and a whole lot of rocket power. In addition to the physical barriers, we'd also need to consider the psychological challenges a 2-minute sojourn on Mercury might present. The intense pressure of such a mission could take a toll on an astronaut's mental health. So, comprehensive psychological support and training would be paramount. And let's not forget about communication. In space, staying connected is crucial. Advanced communication systems would need to be in place to ensure astronauts can keep in touch with mission control, providing real-time updates and receiving vital instructions during their brief visit. Even with these strategies in place, the limited time frame of 2 minutes presents its own unique set of challenges. But with human ingenuity and the relentless pursuit of knowledge, who's to say what's possible? With only 2 minutes on Mercury's surface, every second counts. The substantial time pressure creates a unique set of challenges. Imagine a sprint, but instead of 100 meters, You're racing against the clock on a planet over 48 million miles away. The rapid deployment and retrieval of equipment becomes a paramount concern. There's no room for error. Every move must be precise, every action calculated. Efficient communication with mission control back on Earth is also vital. In the blink of an eye, 2 minutes can slip away, so every message, every piece of data needs to be conveyed quickly and accurately. But what if we could bypass the human element, at least in part? The intense radiation environment on Mercury might necessitate the use of autonomous or remotely operated instruments. These technological marvels could gather and relay data, potentially extending our reach and understanding. Overcoming these challenges is crucial, but the risks to human health cannot be ignored. Exposure to Mercury's harsh environment could have severe consequences for human health. Now let's delve deeper into what these consequences might be. Firstly, the extreme temperatures on Mercury could lead to rapid dehydration. The human body is about 60% water, and maintaining this balance is crucial for our survival. Even a slight drop in this percentage can lead to severe dehydration, which, if not addressed promptly, can be life-threatening. Moreover, these scorching temperatures could also result in heat stroke. This condition occurs when the body's temperature rises above 104 degrees Fahrenheit, leading to a failure in its cooling mechanism. Symptoms include confusion, rapid breathing, and in severe cases, loss of consciousness. Beyond heat-related ailments, thermal burns could also be a concern. The surface of Mercury can reach upwards of 800 degrees Fahrenheit during the day. Contact with materials at this temperature can cause deep tissue damage, leading to severe burns. However, Mercury's threats to human health extend beyond its temperature extremes. The lack of a substantial atmosphere exposes the surface to high levels of solar radiation. Prolonged exposure to this radiation can lead to radiation sickness, characterized by nausea, weakness, and an overall feeling of malaise. Furthermore, this radiation can damage DNA, increasing the risk of genetic mutations and cancer. So, how could humans potentially adapt to these health risks? Well, specialized training would be a key component. Astronauts would need to be prepared to respond swiftly to signs of dehydration, heat stroke, and radiation sickness. Medical interventions would also need to be tailored to these unique challenges. For instance, rapid rehydration solutions and treatments for burns would be essential additions to any medical kit. Furthermore, advancements in technology could aid in reducing exposure to these risks. For example, the development of suits with superior insulation and cooling systems could help regulate body temperature and protect against thermal burns. While the health risks are significant, the potential for scientific discovery may outweigh the dangers. After all, the pursuit of knowledge often requires us to venture into the unknown, pushing the boundaries of what we believe to be possible. Despite the brief visit, Mercury holds a wealth of scientific potential. Even 2 minutes on this scorching planet could offer a treasure trove of information. Imagine, if only for a moment, the fascinating observations that could be made. The surface features, the geological formations, the magnetic anomalies, each one a clue leading to a deeper understanding of Mercury's formation and evolution. Think of the experiments that could be conducted in situ. The extreme heat and radiation present unique conditions that we simply cannot recreate here on Earth. Studying their effects on various materials and organisms could revolutionize our understanding of life's resilience and adaptability. Mercury, despite its hostility to life as we know it, is a scientific playground waiting to be explored. The lure of scientific discovery is compelling, but we must weigh it against the ethical considerations of such a venture. Sending humans to Mercury, even for a brief period, raises important ethical questions. We find ourselves standing at the precipice of a moral conundrum. On one hand, there's the tantalizing allure of new discoveries, the potential to uncover secrets about Mercury, and perhaps our own planet. The prospect of broadening our understanding of the universe is undoubtedly compelling. Yet, on the other hand, we must weigh these opportunities against the risks to human life. Mercury's extreme environment could subject astronauts to grave dangers, from severe burns to radiation sickness. It's a stark reminder of the cost that comes with our curiosity. Balancing the pursuit of knowledge with the responsibility to ensure safety is no easy task. It's a delicate dance between our thirst for exploration and our ethical duty towards human life. As we push the boundaries of human exploration, we must always remember the value of life and our responsibility to protect it.